Okay, question 5, solve for y. If there are multiple solutions, enter them with separate values, and then if there's any extraneous, we need to know. So step 1, we're going to identify the common denominator. We also call that, remember, the LCD, least common denominator. So to do that, we look at the bottoms. I have 12, I have 3y, and then y. So we're going to look at what is the same. Well, these both have a y. So on my common denominator, I'm only going to put one y. Think about it. When I multiply up top by the y, I only need one to cancel out. And then on the number side, I have 12 and 3. So you take the greater number, 12, because 3 divides into 12. So when I put 12 up here, I'm going to get 4. And when I put 12 up here, it's going to go away. So we're thinking about how are we canceling out the things on the denominator. Okay, step 2 is we take those denominators again and we find our restrictions. So anytime there's a variable, we take that denominator and set it equal to 0. And we're finding out what would make the denominator 0. Well, this one, it shows us if y equals 0, that's bad. That's going to put the 0 in our denominator. So that means y cannot equal 0. And this is actually the same thing. If I divide by 3, we get 0 again. So our only restriction is if we get 0 as our answer, we can't. It would make the whole thing undefined. Okay, so now let's solve. So step 3 is multiply everything by the least common denominator. So I have y over 12. See, I'm leaving room. Y plus 9 over 3y equals 3 over y. So I'm going to multiply everything by 12y. And then we're going to get rid of our fractions. Things are going to start disappearing. So 12 and 12 cancel out, and we're left with y times y, which is y squared. Here, like I said before, the y's go away, but 12 divided by 3 is 4. So I have 4y plus 9, which is 4y plus 36 equals, here the y's go away. I'm left with 3 times 12, which is 36. So now we have some simplifying to do. I'm going to look at this. It's a quadratic. So that means we need to set the equation equal to 0. So I'm going to minus 36 from both sides. And I'm left with y squared plus 4y equals 0. Okay, step 4 is solve, I think. I'm going to go back and look at the notes. Step 4, solve. So quadratic has 2 solutions. You can factor or use the quadratic formula. So let's solve. This one's actually way easier to factor because there's 2 terms that have the same thing. They both have y. So if I factor out the y, I'm left with 1y plus 4 equals 0. That's it. We're in factored form. So the first factor we set equal to 0 is y. So y equals 0, and then y plus 4 equals 0. We're going to minus 4 on both sides, so y equals negative 4. So those are our solutions. Y equals 0, y equals negative 4. And I hope that you're thinking, wait, this is a restriction. Remember, y cannot equal 0. So currently, our only solution is negative 4. But our last step, we need to see if it's extraneous or not. So let's go back to our original. Oh, I'm going to go to the graphing calculator and then type it in. So right now I have y over 12 plus y plus 9 divided by 3y, not 2y, 3y, and that equals 3 over y. So what I'm going to do is I'm going to replace y with -4. I already know if I put 0 in, I'm going to get undefined because that's one of our restrictions. So I'm going to put y equals -4 on the left and the right. If they equal each other, it's a solution. If they don't, then it's an extraneous solution. So many y's. Is that right? Y over 12. Y plus 9 over, 3 times -4. I was like, usually they're pretty close. They're the same. Okay. So that means -4 is a solution. And 0 is not extraneous. It's just not a solution. It doesn't exist. Well, maybe they do want 0 there as extraneous. They do. Well, I wouldn't call it a solution, but extraneous solution, it means that it's not a solution. So y equals 0, because if we were to put that in, I'll go back. If I change these to 0, we know what happens, right? We get undefined equals undefined. So if something's undefined, we're going to call it extraneous in this situation.